Okay, I wanted to take one e-learning day, take this a little bit further, and look at the number of solutions. Okay, we're graphing systems of linear equations, and you've done this before, but with a number of solutions. But when we did it before, we didn't have standard form, and we never ended up with a third possibility. Okay, so let's review this a little bit. Okay, when you're graphing two linear equations, a system, and you want to know how many solutions there are, okay, you have three possibilities, not just two like we did earlier. Okay, one possibility is that the two lines intersect. Okay, if the two lines intersect, the solution is going to be the point where they intersect. Okay, that's the definition or the idea you want to think about. The solution to a system is where the two lines intersect. So if they intersect in one point, there's one solution to the problem. Okay, if the two lines never intersect because they're parallel, okay, there is no solution to that system of equations. Okay, if they never cross, there's no point that would be considered the solution to the problem. Okay, there's a third situation we didn't talk about this year. If you graph both lines and they end up being exactly the same line, okay, there's infinitely many solutions to the problem. Let's think about it this way. The two lines are going to intersect at this point, and this point, and this point, and this point. Okay, think about they're going to intersect in every single point on the common line. Remember, that line goes on forever both directions. So there's going to be infinitely many solutions. Okay, so again, that third situation is the only thing new. If the two lines intersect, there's one solution. If the two lines never intersect because they're parallel, there's no solution. And if the two lines actually give you the same line, there's infinitely many solutions. Okay, let's do an example, like what's going to be on Khan Academy. Some of your equations will be in standard form and some will be in slope-intercept form. I chose to do one where both equations are in standard form. Okay, and what I'm going to do when I graph the two lines, because that's what you want to do, I'm going to graph the top equation by changing it into slope-intercept form. And I'm going to graph the bottom equation by using 0. Okay, letting x be 0 and then letting y be 0. So you can see both ways. Okay, so let's look at that top equation. Let's pen to right. Okay, 12x plus 9y equals negative 36. Okay, I'm going to solve this top equation for y. Okay, I'm going to get rid of the added 12x by subtracting 12x from each side. Okay, that's going to leave me with 9y on the left, and then a negative 12x and a negative 36 on the right. Okay, they're not like terms, so I can't combine them together. Okay, now I'm going to get rid of the multiplied 9 by dividing by 9, but make sure you divide all three parts by 9. Okay, we're left with y on the left. Okay, negative 12 ninths. Okay, negative divided by positive is a negative. So it's a negative, but reduce that, because 3 will go into both 12 and 9. So we get negative, 4/3 x. Okay, simplify negative 36 divided by 9 is negative 4. Okay, so the negative 4/3 is the slope, and the negative 4 is the y-intercept. So I'm going to graph the top equation. I'm going to start, I'm just going to use my red line here. I'm going to start with -4 on the y-axis. So I'm going to drag one of the points on -4 on the y-axis. And then from there, I'm going to take my other point, and I'm going to travel down 4, right 3. Okay, so there's my top equation graphed. Okay, now I'm going to graph my bottom equation. But just to give you both ways, I'm going to graph the bottom equation using intercepts, using 0 twice. 4x plus 3y equals -12. Okay, I'm first going to put 0 in for x, find y. Then after I do that, I'm going to put 0 in for y and find x. Okay, that's going to give me 2 points. Okay, so when I put 0 in for x, rewrite the equation, except for putting 0 in for the x. I get 4 times 0 plus 3 times y equals -12. Okay, 4 times 0, this is what's so nice about this. Just ignore it. 4 times 0 is 0. So I really have 3y equals -12. Divide each side by 3. We get y equals -4. Look what we have there. We had x equals 0 and y equals -4. So 1 point is going to be 0, -4. The x goes first. Okay, the other solution, I'm going to replace y with 0 and figure out what x has to be. So I'm going to rewrite the problem, but in place of the 3 times y, I'm going to write in 3 times 0. Okay, so I have 4x plus 3 times 0 equals -12. 3 times 0 is just 0. So I really have 4x equals -12. I'm going to divide both sides by 4. When I do that, I get x equals -3. So I'm going to put those two numbers together. When y is 0, I get x is -3. So when I write it as a point, I need to put my x coordinate first, -3, and my y coordinate, my 0, and write it next, 0. So here's my 2 points I'm going to graph. 0, -4, and -3, 0. So I'm going to take my blue line. I'm going to find 0, -4, down there, on the y-axis at -4. I'm going to find point -3, 0, and graph it. Okay, look what happened. They're exactly the same line. Okay, we graphed both equations, and they ended up being exactly the same line. So every point where they intersect is the solution, but they're going to intersect at every single point on the common line. So we're going to click infinitely many solutions. Okay? Guys, do your best on this. Khan Academy, use the hints. Contact me if you're having any trouble. I want to help you. Okay, this is stuff you're going to do in the 9th grade next year. I'm just trying to give you a real good just a preview. Couldn't think of the word. Giving you a preview of what you're going to do, and maybe it'll be easier next year. Okay, let me know if you have questions.